Okay, let's finish up section 6.3, day 2. And we are starting right down here of the equation of the unit circle is. Alright, well, the unit circle is centered at 0, 0. Radius is 1. So if you remember from way back in chapter 1, the equation of that unit circle is x squared plus y squared equals 1. And we also know, because we're on the unit circle, that the x-coordinate of a point on the unit circle is cosine of that particular angle, and the y-coordinate on that unit circle is sine theta. Well, now making some substitutions, x squared plus y squared is 1. X is cosine theta, so we see cosine theta squared plus y squared, or sine theta squared, is equal to 1. Alright, a bit of notation here is to kind of get rid of these parentheses. And the way we can write this is cosine squared theta plus sine squared theta equals 1. That is an important equation called an identity, because it is true for all values of theta. No matter what theta is, this statement or this equation is true. That's called an identity. I do want to caution you about the notation here, and that is that cosine of theta squared is not the same as cosine squared theta. And this one, the theta or the angle is what's squared, and then the cosine is done on that. And this one, cosine theta is done first, so we find that x-coordinate first, and then square that x-coordinate. They are not the same thing. Watch your notation here. Alright, now we're going to find a variation of this identity if we take each term and divide by cosine squared. So we'll have cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. When we simplify, we will get 1 plus tangent squared theta equals secant squared theta. That also is an important identity, true for all values of theta defined in that equation. So where tangent is defined and where secant is defined. One more variation, and going back to this original identity here, and instead of dividing every term by cosine squared, let's divide by sine squared. So we'll have cosine squared theta divided by sine squared theta plus sine squared theta divided by sine squared theta equals 1 divided by sine squared theta, which will give us cotangent squared theta plus 1 equals cosecant squared theta. Another variation. These three variations here, these three are collectively called the Pythagorean identities. Because they're all coming off of that Pythagorean theorem on the unit circle. X squared plus y squared equals that radius or that hypotenuse of 1 if we draw a triangle. You need to memorize these three. You need to memorize these three. Cosine squared plus sine squared is 1. That shouldn't be too difficult to come up with. These, the 1s and the tangents and the secants, they all get kind of mixed up. Here's how I think about it. This plus sign almost looks like a T. So the tangents are with the plus 1s. The cotangent, which has a T in it, is also with the plus 1. So tangents and cotangents have the plus 1 next to them. And then the cotangent goes with cosecant. And tangent and secant. So no co-functions here. These ones down here have the co-functions. So that's one way to memorize it. However you choose to memorize, you just need to memorize them. All right, let's look at some examples that use these identities. Here's the first one. Cotangent squared 25 degrees. Whoa, not cotangent, I'm sorry. Cosine squared 25 degrees plus sine squared of 25 degrees. Well, that's exactly that very first identity. Cosine squared theta plus sine squared theta is 1. All right, look over here. Secant squared 18 minus tangent squared 18. Well, this has secants and tangents in it, so we go back to that identity, which again was tangent squared theta plus 1 equals secant squared theta. So over here, the 18's taken place of the theta, but look at this. If you subtracted tangent squared from both sides, we'd have secant squared theta minus tangent squared theta, which would be 1. Nice. All right, look at this one. The sine of 92 times cosecant 92. Well, sine of 92, whatever that is, times cosecant of 92. Well, cosecant of 92 is 1 over sine of 92. Put that sine of 92 over 1. Oh, and look at that. Sine 92, sine 92, those cross cancel out, and we were left with 1. All right? Boy, I wonder if all these answers down here are also going to be 1s. All right, let's look at tangent of 200 times cotangent of 200. And we're in a bit of a quandary there because we have 200 degrees and 20 degrees, and that's an issue. So what we can do is write this as the sine of 200 divided by cosine 200 times cosine 20 divided by sine 20. Okay, let's look at where 200 and where the 20 degrees is. 20 degrees, right there. 200 degrees, right there. Look at those two. Those are exactly halfway across the circle. They're exactly pi apart from each other. So what I want you to do is look at the sine of 200 versus the sine of 20, S-I-N. Sine of 200 is negative. That's the same, well, the same numerical value as the sine of 20. Just the sine of 20 is positive and the sine of 200 is negative. So we could say that this sine of 200 is the opposite of the sine of 20. Now, how about cosine 200 versus cosine 20? Cosine is the x-coordinate, so cosine of 20 degrees is some positive amount. Cosine of 200 is some negative amount. They're exactly halfway around the circle from each other, so the numerical values are equivalent, just the signs are opposite. So the cosine of 200 degrees is the same as the opposite of the cosine of 20 degrees. And then we have cosine 20, sine 20. Now all of our angles are the same, so look what we have. These sine 20s divide out. These cosine 20s divide out. And these two negatives right here divide out. And we are left with 1. Oh boy. All right, look at this next one. The secant of negative pi over 18 and the cosine of pi 17 pi over 18. All right, secant is 1 over cosine of negative pi over 18 times, this is cosine of 17 pi over 18. We cannot just cross those out right now because that's a negative pi over 18 and that's a 17 pi over 18. We need to look at a circle and see how these guys are related. All right, negative pi over 18, down pi over 18, so this much down. There's negative pi over 18. 17 pi over 18, where's that? Well, that's 1/18 shy of pi. So pi would be over here, but 1/18 pi shorter than that. So right there, there's 17 pi over 18. Huh, this is pi over 18 going down. This much is pi over 18 going up. How far apart are those guys? Yeah, those are exactly halfway around the circle. Look at their cosine values, please. How is the cosine of 17 pi over 18 related to the cosine of negative pi over 18? Cosine here, which is the x-coordinate, versus the cosine there, they are just opposite signs. So we can take this right here and say that the cosine of negative pi over 18 is the opposite of the cosine of 17 pi over 18. Oh, look at that. And we just ruined our record because this one does not multiply to be 1. This one multiplies to be -1. All right, how about this next one? Sine 70 divided by cosine of -430 plus the tangent of -70. Oh boy, we have 3 different angles to look at here. Let's see. Here's 70 degrees. Where's -70? Down here. And -430 is -360 gets us around once, and then we have how much left over? Yeah, another 70, so right down there. So this -70 is also -430. So right here in this line, we can write this as sine of 70 divided by cosine of -430, which is also -70, plus the tangent of -70. All right, so looking at all of this, I have a -70 here and a -70 there and a +70 here. Why don't we change this +71 into a -70? So the sine here at 70 degrees compared to the sine at -70. Y values, those are opposites. So this sine of 70 is the opposite of the sine of -70. And look at this. Sine of -70 divided by cosine of -70, that's the tangent of -70, but negative, plus, and over here, the tangent of -70, oh, 0. They take time. You have to think about where points are on this circle and then compare those particular values. All right, one more little thing that we need to talk about today, actually two more things. These are kind of disjoint things, but they all kind of come into play a little bit later on. Do you remember about even and odd functions? We said an even function happens when the graph is symmetric about the y-axis. And odd functions, we said, are when the graph is symmetric about the origin. Oh, beautiful definitions, but we have a problem with that. And that is that we don't know these graphs yet. Yet. It's a coming. All right, so we need to go back to our original definition for even before we talked about graphs. And a function is even if f of the opposite of x is exactly the same thing as f of x. And a function is odd if f of opposite x is the same thing as opposite f of x. So let's look at a circle here and see if we can figure out which functions are even and which ones are odd. All right, so both of these are comparing x and the opposite of x. So let's find an x value here. Then opposite of x is right down here. Okay. Let's just start looking. Cosine. Is the cosine of this value of this x exactly the same as the cosine of negative x? Yes. Cosine of negative x is the same thing as cosine x, so cosine is even. Okay, how about sine? The sine value here at this x versus the sine value there at x, or this negative x, they are opposite signs. The sine of opposite x is the opposite of the sine of x, so sine is odd. How about tangent? Tangent of these two spots, same or opposites? They're opposites, so tangent is odd. How about secant? The secant here and the secant here, well, that's the reciprocal of cosine. So if cosine's even, then secant is even. Cosecant is also odd, as is cotangent odd. So cosine and secant are both even. This looks like a fraction. I got to white out this bar here because I don't want you to think it's a fraction. Cosine theta and secant theta are both even functions. Sine theta, tangent theta, cosecant theta, and cotangent theta, these guys are all odd functions. All right, one more example here today. If f of theta is cosine theta and f of a is 1/4, I want you to find f of the opposite of a. All right, well, the f function is cosine. So this is actually telling you to find the cosine of the opposite of a. Well, where's a? this is saying the cosine, that's f, cosine of A is 1/4. Cosine's x coordinate on the unit circle, so we can come out about 1/4. And it's right there. There's that angle. And that's, oops, I don't mean to put it, yeah, theta is okay there. There's A, that spot right there. That's the x coordinate. Well, where's the cosine of negative A? Where's negative A? Right down here. There's negative A. So the cosine of negative A is 1/4. Alright, now look what this one's telling us. This f is this cosine function, so this is saying cosine of A plus cosine of A plus 2 pi plus cosine of A minus 2 pi. Well, what is the cosine of A? That's 1/4. Plus, how about, where is A plus 2 pi? A plus 2 pi is right back here, and that cosine value is 1/4. And the last one, cosine of A minus 2 pi, back around same spot, so that is also 1/4. And when we add these together, we get 3/4. Okay, and the last page has been left blank for your viewing and doodling pleasure. Thank you for tuning in. Please use the remaining time today to catch up on any homework that you need to do, and we'll see you next week. Thank you.